Lesson 14, Transient Response. Section 14.8. Response to sudden sinusoidal excitation. Let's study how to derive transient responses when the source voltage is sinusoidal. At t equals 0, the switch is turned on, and a sinusoidal voltage is suddenly applied to an RC circuit. This waveform is an example of the voltage VRC. Theta is a phase angle of the source voltage V. This is similar to what you probably do every day when you turn on home appliances. This is the differential equation of RC circuit. The voltage VRC is given by this equation. Vm is the amplitude, and theta is the phase angle. For t is equal to or greater than 0, VRC is replaced with Vm sine omega t plus theta. Let's assume that the charge Q of the capacitance C is given by this equation, where A and B are constants, and psi is the phase angle of the RC circuit. The first two terms represent the transient response, while the third term expresses the steady-state response. By substituting the assumed equation for Q into the differential equation, we obtain this long equation. We can simplify this term. Thus, the constant B is determined. The initial condition is, for example, at t equals 0, Q equals 0. Then, the constant A is determined. By substituting A and B into the assumed equation, we have this expression for the charge Q of the capacitance C. From this equation for Q, Vc, and Vr are derived as shown in these equations. These are the calculated waveforms of V and Vc, under the condition that, at t equals 0, V changes from 0 to Vm sine omega t. The parameters are Vm equals 2 volts, F equals 15 kHz, and theta equals 0 radian. These are the experimental waveforms of V and Vc, under the same condition as the calculated waveforms. These results met the calculated waveforms fairly well. Exercise 14.8. This is your homework. Find the phase angle theta at which no transient response occurs in this circuit. These are the calculated waveforms. For t is equal to or greater than 0, Vc shows no transient response. These are the experimental waveforms. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.